Okay, so just going to go through question 2BII for the 2017 AS1 paper. Okay, so in the question, we were asked to find, we were given the length of our of a piece of conductive putty in a solid cylinder. We're also given the diameter of this putty, and then the current and the potential difference, which we used to find an average value for the resistance, which was 18.08 ohms. Okay, so the resistance here is 18.08 ohms. Using pi r squared to find the cross-sectional area of our cylinder of putty, I was able to find the cross-sectional area to be 1.2 times 10 to the minus 4 meters squared. Okay, converting, of course, the radius, which was half of the diameter, converting that into meters, and using that to find the value for our area. So, doing the question that's being asked here is the resistance of the new piece of putty of length 6.2 centimeters. Okay, so what we have to do here is figure out what the resistivity of the putty is using what we have so far. So we have all of this information, which is handy because we know our resistivity equation looks like this. Rearranging that gives RA is equal to over L is equal to rho, rho being the symbol for resistivity. Okay, so I'm just going to quickly do this on my calculator. We've got 18.08 times 1.2 times 10 to the minus 4 divided by the length, which is 0.053. Okay, so I'm getting a resistivity here of 0.0409. So resistivity is equal to 0.0409, and it's 358, so I'm going to say 36 just to get some significant figures in here. Okay, so using our new length, we're going to have 6.2 centimeters. So the volume stays the same. So what was the volume of the old putty? So volume is equal to pi r squared h. So that's going to be pi times r squared, which is 6.2 times 10 to the minus 3 squared, times the length, which is 0.053. So our volume here is going to be equal to pi times 6.2 times 10 to the minus 3 squared times 0.053. Which I'm getting as 6.4 times 10 to the minus 6 meters cubed. Okay, so working this out now for a new value of h being 6.2 centimeters, we've got 6.4 times 10 to the minus 6 is equal to pi times 6.2 times 10 to the minus 2 times r squared. So we need to find our value for r so that we can get our cross-sectional area. I'm going to go into blue now just to show that we're doing the new one and differentiate get a difference between that and the old putty. Okay, so we've got 6.4 times 10 to the minus 6 over 6.2 times 10 to the minus 2 pi, and we're taking the square root of that to find our radius, which is going to be equal to, just give me a second on the calculator, square root of 6.4 times 10 to the minus 6 over pi times 6.2 times 10 to the minus 2 gives us 5.73 times 10 to the minus 3. So 5.73 times 10 to the minus 3 meters is our new radius. So using this to find pi r squared, not looking back, to find pi r squared, which is our cross-section area, all you needed to do was velocity or volume over the height. But nonetheless, pi r squared is going to be pi times 5.73 times 10 to the minus 3 squared, which gives 1.03 times 10 to the minus 4. Okay, so we know the resistivity, we know our cross-section area, and we know our length from the start. So we can now do resistance is equal to rho L over A, which is equal to 0.040936. I'm just going to move this slightly. Times by our length, which is 6.2 times 10 to the minus 2 to keep it in meters, divided by our area, which is 1.03 times 10 to the minus 4. Okay, so we've got 0.040936 times 6.2 times 10 to the minus 2 over 1.03 times 10 to the minus 4, which gives us, which I'm getting a value for resistance of 24.64 ohms. Okay. The answer on the mark sheet, mark scheme is 24.7 ohms. So the error here is bound to be by me not going to enough significant figures, probably with the area. Okay. Let me know if you want any other questions. Cheers.